Hi guys, previous video I took apart one of my KRATAX lithium-ion batteries. These ones have got a circuit board inside to give you 1.5 volts out. So even though it's a 3.6 to 4.2 lithium-ion battery, the output will be a steady 1.5 volts regardless of the lithium-ion battery's internal power. It's also got built-in overcharge and over-discharge protection. And out of the pack of 4 that I bought, one of them wouldn't take charge. And I was guessing it's probably over-discharged where it's been in storage. So the circuit board in there would not allow you to put charge into it. That's what I think has happened. So, we took it apart. So that would normally be on the end there, making it a normal AA battery length. So this one's just a bit shorter than a normal AA. And if we measure the voltage on it, can we see that? Yeah, I think we can see that. It's actually got about 2.4 volts in it. And a lot of these protection circuits and that will refuse to allow you to charge it if it's less than about 3.2, 3.3. So I think that's what's happened. This is over discharge when it's been in storage. So when you try to charge it, it says no thank you. So what I've done, just for demonstration purposes, we'll have a look at one of these. So this one will tell you 1.5 volts. I'll get my fingers out of the way. There we are, 1.53 there. So the actual lithium-ion battery in there is probably at 4.2, and the circuit is dropping it down to 1.5. The seller did send me 2 replacements to replace the 141, so I'm quite happy with that. And what I'm going to do now is I'm going to put it in here, because although it's shorter than a normal AA battery, there's enough spring there to bring the end up. Actually, there isn't just there, because that's got a little plastic tag in the way, but I'll put a little spacer in there so that it actually, can we see that? There's actually a gap there. I'll put a little spacer in there to bring it up to the full length, and then we'll see if we can put some charge into this one with my LiPo charger, or my battery charger. We'll set it to lithium ion, which it is, and we'll see if we can put some charge into here. I've got a screw in there just to fill up the gap so that the battery's in circuit. These others are just dummies. The yellow one is one I bought a set of them. They've just got a straight through metal strip in the middle to give you connection between there and there. The red one and the blue one are ones that I 3D printed and made into dummy batteries. That one has got the end caps off of ordinary AA batteries and a bit of wire soldered between them, so that's straight through. That one's even simpler. That one's 3D printed AA size with a nail up through the middle to make the contact. So what we should have, if I go on the end of here, we have our 2.4 volts. So So if we plug that into my charger, which is set for lithium-ion batteries, it might charge it, or it might say low voltage. So let's start. I've got it set to 0.8 of an amp, 3.6 volts. Connection break, doesn't like it. Disconnect that again. Just double check that we have actually, yeah, we're all the way there. So what we're going to do now is tell the charger it's not charging a lithium ion, it's charging something like a nickel metal hydride. So stop that. Lithium ion, nickel metal hydride. Now start it. It'll only charge at 0.2 of an amp. 0.2. And away we go. So we're now putting voltage into it. I don't know how clear that is on the camera, but that's 2.7, 2.8. Once it's got up to about 3 point something, we should be able to switch it back to lithium ion and it'll charge it properly. I'm not telling you to do this. This is the way I do it. There's the potential for your batteries to catch fire and explode if you get it wrong. But this works for me. The main thing about this is you tend to forget that you've got it plugged in and wander off, and you end up, the nickel metal hydride charge will keep pumping power into there. It does actually stop, but it might be charging it at a different rate to what you would want for lithium ion. Having said that, as you can see, it's down to 0.1 of an amp. We're up to 3 volts as well. So it's charging it very gently. We'll let it get up to about 3.2 and see if that'll be enough to swap it back to lithium ion. And we're up to 3.2, 3.26. Then it drops back again a bit. So I think that might be high enough to switch back to lithium ion. Lithium ion, start, 0.8, 3.6. Yep, it's happy now. It's taking charge. So we'll come back in a while and see if it's got up to 4.2. Well, it's been on charge for a couple of hours now. It hasn't actually said that it's finished charging, but I just thought I'd measure it and see what we've currently got. So I've disconnected it. .87. Well, that's not 4 point something, which is what I would expect when it's fully charged. But that's certainly more than the 2.4 volts it had when we started. So it's taking charge. I'll put it back on charge. And see how it gets on. Well, the charger alarm has just gone off to say that it's fully charged. Still only registering 4.1 volts, whereas I would have expected it to go to 4.2. I'll turn that off. Disconnect that. Switch the meter on. And we'll go straight across here. 4.09, so yeah, 4.1. Which is a tiny bit lower than I would have expected for a light lithium ion fully charged. It's got a little bit of warmth to it. It's not hot by any means, but it's not cold. So on the face of it, it's charged up. What I should have done was sorted out something we could use to discharge it and see how long it lasted. I wanted to use that just to run the battery down and demonstrate how long it was lasting. But the gear on that motor is sliding up and down the shaft, so it's failing. So I'm going to try instead just directly attaching this wheel to it. Which we might be able to see the white bit going past. It's going to spin too fast, but we'll see how we get on. Clock's there. That is the current time. 18 minutes past 6 in the afternoon. Okay, let's see what happens. Spinning too fast. We can't see the white light or the white line. But we can at least leave it running and see how long it lasts. The bottom line is we're getting some useful power out of that battery. Well, I'll leave the camera running and I'll come back later and see if it's stopped. I'll play the video back and find out how long it lasted. Obviously we've got no over discharge protection on there, so it'll be lower than it should be. Oh yeah, we've run it right down there. Completely flattened it, 0.5 volt. You shouldn't do that. You shouldn't run it right down like that. Having flattened that battery again completely, I thought I'd better see if we can recharge it again. So I put it back on charge. We now are up to full charge according to the charger. Still only showing 4.1 volts, which I think is a bit low for a lithium ion, but that's obviously what it's going up to. So if we disconnect it, I should have turned that off, shouldn't I? Okay, so can we see the meter? Yes, on there and on there. 4.08. So yeah, it's charged back up again. So it may be a useful battery for what it is, if I can think of a use for it. So thanks for watching. Don't forget to like and subscribe. Leave us a comment so I know how I'm doing. And somewhere up here there'll be some links to related playlists. Thanks again.